Hello guys, this is going to be a different tutorial series. This series will cover the access tier and ladder application of Aveva Pdms in detail, both the creation of different things like stair flights, stair towers, ladders, platforms and rails, and also it will cover the administration part of all these things in very detail. And there will be another series that will cover staircase, lateral, and handle application of everywhere each both the creation of the previously mentioned things and the administration part of the same in very detail. Okay. And other series of structural joints and fittings will run simultaneously. In this episode, we will start by explaining how to activate this access tier ladder application first, and then we will discuss how to incorporate the required database so that we can modify administration parts. And after that, we will check how to create components, and at last we will see the administration workflow in very detail. So for that, first of all, we have to go to add-ins. Okay. In Aveva plant PDMS UI design, there is one folder called add-ins. Now, naturally, if you install PDMS at very first, then under the structure, there will be only four options. One will be beams and columns, one will be planes and plates, one will be walls and floors, and the last will be airs and modules. This access steering ladder application will not be visible for some. So to enable that, you have to go to add-ins, this folder. In this folder, you will see one file named ASA. Okay. You have to open it with Notepad or something like that, editing software. For some cases, if there are hash before these lines, okay, then these lines will not operate and this module will not be displayed in the design. Okay. So if you have hashes before these lines, okay, name, directory, show on mail, like this. If you have hashes, you just have to delete those hashes and you just have to save this document again and just close it. After doing that, you will be able to see this access tier ladder module under this structure again. Now, if you go to any site, okay, yes, if you go to any site and zone and structure, and if you click on this create stair flight options, or you can go to here on create and stair flight, if you click it, you will get one error like this. Stair flight criteria not set for setting reference. Contact your ASL administrator. Why it is saying that? Because the required database to modify all this stair flight and ladder things is not included in our master database that we are currently working on, and we are currently working on the sample master database. So for that, we have to include the ASL config database into this master database. So for that, just we have to close this design, okay, and we have to go to this. We have to open the admin module first. So just open this one. After opening this admin module, we have to go here, okay, this element step, and from here we have to choose our entities. Okay. Currently, we are working on our sample entity. Okay. This is our sample master data. We have to modify it to include the required ASL config database. So for that, first of all, you have to click here and you have to click on modify. Okay. So after clicking on modify, as you can see that this is the admin ASL config basic design database. Okay. This is the design database. So it is not included currently. These are all the included database. So we have to include this database into this stream. So for that, just click here and click this drop down menu. So now, as you can see, that this admin ASL config database is already included in our master database, that is sample database. Okay. So after that, we will click on apply. Okay. And we will click on dismiss. We will just save it. So now this required database is included in our master database, as you can see. Yes, this one. So now we will close this admin and we will reopen our design. So just give the password. And as you can see, we are choosing the sample master database that we have currently modified. That will log in. This database has been modified and this application data words are currently visible, which will be required for our ASL configuration thing. Okay. So now what we will do, first of all, we have to go to the structures and access tier level that we are currently in. Okay. So after that, we have to click on settings. Okay. So after settings, we will click on ASL storage area. This will be our storage spaces for our standards and substandards. Okay. So after that, as you can see that this is the standard and this will be our settings. Okay. So in our case, this is our application data world. Okay. APPLDW or application data world. This will be our storage space for standards. Okay. These are our four standards. This is the metric standard, this is the British standard, this is the example standard, and this is the assembly application data. So all these four standards are stored under this application data world. So this is the storage space for our standard. Okay. So we will click on this application data world and we will click on. Okay. After that, we have to select the storage space for our setting. Okay. So currently we can use any of these settings, but as you can see that there are 5 settings. These are the 5 settings. These are two created by me, and these are the default Aveva settings. And all these 5 settings are stored under this application data area. Okay. These are the application data, and this is the application data area. So this is the storage space for our settings. So for that, we will click here and we will click on sleeve. Okay, so as you can see, it is also linked. So our standard storage space is linked and our setting storage space is also linked. What you can do if you want, you can also link the storage space for the structures that you are going to create. Suppose if you want to create all the stairs or ladders under this structure, so what you can do is set storage for all elements, and after that you can click on C. So as you can see, this structure is linked for all the storage spaces for the stair tower, stair flights, ladder, platforms, and okay. So after that, we will click on apply and we will be discussed. Now, all of our standards and setting storage spaces are highlighted and linked. So what we will do now, first of all, we will go to the setting and we will go to ASL setting. So this is our setting. So for many of you, no such settings will be displayed. There is some cases. So for that, you can just create one new setting. But for our case, our settings is already here. So we are currently not creating this a new setting. So for our reference, we will just click this test two. This is our setting, and this will be using this standard. Okay, this will be using this standard, availability standard, and the secondary standard will be public. So after that, we will open another window that is settings and ASL standard. So this is also open now. So as you can see that this is our standard. Okay, so how is this getting this standard? This is getting this standard by following this application data world. Okay, so the application data world containing the 4 different standards. So it is getting this 4 different standards. Okay. This is the ASS standard, this is standard and ASS standard example. This is the two standard, ASS standard, ASS standard example. And under this application data world, as you can see that there is these two standards, the IASL British standard and IASL example standard. The British standard and the example standard. So for our case, we will be using this British standard and we'll be using the standard of public. Okay. So now what is it doing? So for that, to understand the basic workflow, first of all, we have to create a stair. So for our case, we have already created a stair tower previously. So let me just add it so that we can make some reference point for creating the stair. We will be discussing how to create the stair towers and its assemblies in detail in a later episode. Currently, we will be focusing on stair flight first. Okay. So for that, we will click on this structure and we will just let me close this one first. So we will go to create and stair flight. Okay. And this option is already set as stage 2. Okay. So for that, first of all, we will click on straight and we will be picking our upper work point. Okay. So this is our upper work point and we will be picking our lower work. And this is our installation option. And straight, we can also choose the L shape, S shape, and U shape. For simplicity, we will be choosing the straight for understanding all this. We will put this assembly portion as default. We will be discussing it later. Okay. After that, we will be creating evaluate flight. Okay. As you can see, that the flight has been evaluated correctly. Okay. No errors as such. After that, we will handle for handle. We will just click on done so that it will be simpler. Because in this portion, we will be discussing only on stair flights. After that, we will again click on evaluate stair flight and we will click on create stair. So as you can see, there are stair flight has been created. So after that, you can just remove this stair tower because it was only for our reference for creating this stair flight. So now, how it has been created, we have to understand that. So let me just close this window. Just let me save it for. So what is the basic hierarchy? Let me. So we have to open this ASL standard. So as you can see, if I go to here and modify stair flight again, you can see if you click on this detail attributes, you can see this whole dialog box. How is this dialog box is being populated? You have to understand that. So after we pick the upper work point from a reference point and the lower work point from another reference point of plane or something like that, then the ASL machine will calculate this will calculate the rise according to the formula. According to the formula, that formula we have to determine. We have to tell to James which formula to use. That I will cover slightly later. In this case, according to a certain formula, our overall span has been given here. Okay, our overall span has been given here. As you can see, back to modified side, our overall span has been given here. That is 7 meter. Okay, and this minus this is 7 meter. Okay, and our upper and lower elevation point has also been determined by our peaking points. And as you can see, that the overall going and overall rise has been calculated from that. Okay, the overall going and rise. After calculating that, DMS is using a certain formula to calculate all these intermediate values. Okay, this grade out values have been calculated by that formula. Okay, and you cannot change these values. Okay. These are the calculated values based on the peak upper work point and the peak lower work point. So these grade out values cannot be changed. What you can change is the width of the stair, the flight thickness, the headroom. This you can change. If you click on this button, the same dimension will be displayed here. This is the width. If you click here, this gap is the flight thickness. If you click on here, this is the default rise, something like that. So all these non-grayed out parameters you can change. Okay. And if you change all these parameters and if you go to back to modify pad and re-evaluate, it will be re-evaluate this stair again, and all these grayed out parameters will be changed based on the values that you will input in this non-grayed out data, apart from the previously defined upper work point and the lower work. So after completing the calculation, PDMS is getting all this grayed out data. So now what PDMS will do? So first of all, PDMS is calculating according to the previously defined formula, and PDMS is getting this value. Now, if you come to the settings and ASL standards, this window will be displayed. And as you can see, under our British standard and our staff standard as public, under this Stair Flight, okay, under this Stair Flight, you can see that there will be certain minimum and maximum values, okay, and a default or optimum value has been displayed here. Okay, these values will be the guiding factor for the validation of the calculated value. Okay, so suppose as you can see that the rise of the bottom tree, okay, or the lower rise, or maybe the rise, these values should fall under this minimum and maximum category. As you can see that the calculated lower rise in our case or the rise in our case is near about 150 mm, which is in between the minimum and maximum that is previously defined under this standard. Okay. So if you define two points, one upper work point and lower work point, as such that the calculated value is something beyond this range. Suppose if you pick two different points, suppose one upper work point and lower work point, such that the calculated lower rise is 75 mm or the rise is 75 mm. Okay, that is below the minimum value defined by the standard, then you will get one error that will say that a stair cannot be created using the defined or the given parameters. Okay, so this is how PDMS is evaluating that whether a stair can be created or not, depending on the minimum and maximum values of all these grayed out parameters that is previously defined under this standard. So now we will go to our standard. So if you just go to the standard under this Stair Flight category, you can see that there are different data. So what are these data? Data point. This is the data set of the Stair Flight, and these are the data points. So what is this data point doing? This data point is simply referring this value. Okay. So if you just click on here right click, and if you click on attribute, you can see that this is telling you the Stair Flight intermediate landing length. Okay, Stair Flight intermediate landing length. Okay, and as you can see that the default value is 800 mm and the maximum is 100 and 5000. And here also you can see that the intermediate landing length is 100, minimum 5000 maximum, and 800 is the optimum value as defined by this data point. Next data point you can see that with the stair flight thickness there is the minimum 50 and to 1000 and 150 mm. You can again check here the thickness is 50, 1000 and 150 mm. So all these values, if you go here, is referring to this points. Okay. So this is our standard. You will refer the minimum and maximum values here. If you change the values here, it will be changed here also. Okay. It will be changed here also, and you can also change it here. You can change it here, and it will be reflected here. Just vice versa. Right. So suppose this is our stair flight going value. This is the stair flight going value, and as you can see, 150 and 350. the stair flight going here. And if you check here, you will find that this is the going. Okay, so if you want to change this going to minimum going like 100 or 150, and if you click on this accept changes, as you can see that this corresponding value has been changed from 150 to 100. So you can just change it here, it will be reflected here or vice versa. Okay. So I will just change it to what it was previous to 150, and I will again click on accept changes, and as you can see it will be changed here. Okay, this accept. So all these data points are previously mentioned under our standard. Okay, we are defining the maximum and minimum values that PDMS will be referring while creating a stair. Okay, so all these values are previously defined. Now, if you check all these data points, you will find one data point that will be including the stair relationship. Okay, so this is the stair relationship. There are other relationships like rise plus going or rise into going like that. But currently PDMS is using this 2 into rise plus going type of relationship. This relationship is being used by PDMS for creating this stair flight. So what PDMS is doing, first of all, we are picking one upper work point and one lower work point. So based on our pick of this upper work point and lower work point, PDMS is using this stair flight relationship formula. Okay. PDMS is using this stair flight relationship formula, and using this formula, PDMS is populating all these parameters. Before populating all these parameters, PDMS is checking whether all these parameters is falling under the minimum and maximum predefined values by the stair flight standard. Okay. If all these values are falling under this minimum and maximum criteria, then PDMS will populate all these values, and if you click on create stair flight, the stair flight will be created. Okay, this is for normal category stair flight. If PDMS will find that one calculated value is beyond this minimum and maximum range, PDMS will show you one error that a stair flight cannot be created using the given parameters. So now this is the general hierarchy of a standard stair flight. Okay. So now how this stair flight has been created. Okay. So PDMS is getting all these corresponding values, but how this stair flight is physically created. So for that, what we have to do, we have to open another tab. So we have to go to setting, and we will click on ASL setting. This will contain this one, the ASL setting. This will contain all the assembly sections. Okay, for handrails, for ladders, for platforms. In this section, we will, in this episode, we will discuss only for stair flight. So if you click on stair flight, as you can see that suppose if I click here, we will be able to go. This is the default trigonometric setting that is already available here, and this is currently referring from here. Referring from here, the trigonometric setting. So if you click here, okay, if you click here, you can see that there are 5 assemblies. These are the predefined Aveva assemblies. These assemblies will be used. These assemblies will be used while creating this layer. How? Now the question is, so under this application data world, you can see that there is one application data area called ASA assemblies or area. So just open it. Under that, you will find one application data under that zone, and under that you will find structures for stair landing or stair flights like that. So after opening the structure, you can see that there are 5 different stair flights that has been previously created. Okay, this will be used. These stair flights will be used for references, for instances, while creating a stair flight in design. Okay. These stair flights will be used for creating instances while creating this stair flight in design. How? Suppose if you click on this stair flight and if you open the attribute tab, just let me leave this one a bit. As you can see that there is one assembly template reference. Okay. There is one assembly template reference. And if you just copy it, you can see just by referring it that this template is nothing but this stair flight. Okay. This template is nothing but this stair. So what PDMS is doing, PDMS is using this assembly template to create our stair flight using the data that it has already calculated by our upper and lower work point and other given data. So in this assembly selection for ASL application, you will find that this standard will correspond to assembly item like that. Okay. So as you can see that there is currently 6 assembly items. This last one is created by me. So the default are the 5 ones. So this trigonometric default setting will be contain only these 5 ones. Okay. This one, the setting that I have created will contain the last one. Okay. You cannot just include a setting that you have already created here just by clicking here. For that, If you suppose if you create another stair flight or something like that, you have to create another setting so that the newly created assembly will be incorporated here. Okay. I will be showing that later. So now currently there are 5 standards in the default setting. Okay. These are the descriptions of this stair flight. This is the standard, this is the curved tree work, this is the curved tree vertical work, like that. So what PDMS is doing, PDMS is first calculating all the grayed out values that I have already discussed, and after that, after the validation of all those previously created values, PDMS is currently referring this assembly item. Okay. How this assembly item has been referred? Let me just close this window, and again we have to, for that we have to open the modify step. In this modify step, like you will find one assembly portion. Okay. So as you can see under this step, like as you can see that again this is the standard, this is the curve kit. All these things are shown because I just click this one. If you click on the default, it will change, right? If you click on this default metric settings, as you can see that the default metric settings is on only contains the default metric only contains the 5 assemblies. Only these 5 assemblies has been displayed here. So these are the 5 assemblies. I have selected the standard one. I have selected the standard one. So after selecting this, PDMS is referring this standard assembly set. Okay. And after that, it is assigned as true. If you change this to false, it will not be displayed here. Okay. If it is written as true, only then it will be displayed in this dialog box. So after that, PDMS will refer this assembly item and will create an instance of this assembly item into a stair flight. Okay. So suppose if you just click here and if you change this to curve tree, okay, and you just evaluate. Now, as you can see that this stair flight has been changed. How it has been changed? So again, if you go to settings and ASL assembly settings, you will find that under this text, under this stair flight, this is there. This is the second option that I have chosen. That is the curve tree. Okay. So after calculating all the grayed out values, PDMS is using this assembly option. STR equity cater 2. Open this attribute, you will find this assembly detected paper. This is the cater 2. Okay. What PDMS is doing? Just let me open again this application data word and this assembly application data. Okay. So under this, we'll find the stair flight structure and other things we'll find. So under this assembly section, as you can see, that in the previous one, the only the R path is defined. Okay. In the previous one, as you can see, only the stair flight has been created. Okay. No such sections or different trees. Here, as you can see, the trees are a bit curved. Nothing like that has been created previously. Okay. So now, how all these things have been created? As you can see, that apart from the reference path, R path, this street thing, okay, the street set and this street has been predefined in this thing. This thing. This and this stair structure also. As you can see, this specification reference, everything is defined that is being used for this thing. Okay. So after calculating all those grayed out values, PDMS is using this assembly template. Okay, PDMS is using this stairflight as a template, and PDMS is using this tree for its use. Okay, for creating this trees. And again, if you go to this 5, but I think it is for, as you can see, there is no sections or something like that. This is for complete state. So again, if you go to click here, if you go to modify stairflight, and you check here and configure feeds, evaluate stair flights and update changes. And you can see that the complete stair flight has been generated. Okay. So how PDMS is knowing that? Because PDMS is following this assembly. PDMS is following this assembly. Okay. So this is the total working process. This is the total working process of how PDMS is actually operating this total ASL thing to create our request stair flight by using our given points. Okay. So just let me go through it once more. The total work. So what is happening? Again, we have to click here and modify stair flight. So first of all, we have to choose our installation options. Okay. Then we have to pick our upper work point and our lower work. After picking that, just let me again open this standard also. Then it will be easier understanding. After doing that, PDMS is evaluating the stair. PDMS is evaluating the stair. How? PDMS is evaluating the stair using a certain formula that will be described under a data point. Okay, under data point, under data set of our current standard. Okay, so this is our current standard. This is the data set for stair flight, and this is our data point. The data point number 8. This is our given formula to PDMS. After giving this upper work point and lower work point, PDMS is using this formula. PDMS is using this formula to calculate all these attributes. Okay. PDMS is using this formula to calculate all these attributes. The grayed out parameters cannot be changed. You can further change the non-grayed out parameters like flight width or flight thickness or headroom like that. And again, it will re-evaluate and populate this grayed out parameter. After populating PDMS, we'll check whether all these parameters will fall under the previously defined min-max value of the same parameter. Okay, these min-max values have been defined under our public application data in this data set of Stair Flight under this data point. All these min-max values have been defined previously by our standard and our standard. So PDMS will then evaluate whether the newly calculated values will fall under this min-max category or not. If the value that PDMS is calculated using our upper work point and lower work point, if the calculated values will not fall under this minimum and maximum value criteria, then PDMS will show us an error as the flight cannot be created using this given parameter. But if the calculated value, all the calculated values will fall under this min max criteria, this is the just optimum value, nothing else. So if all the grayed out values will fall under this min and max criteria, then PDMS will go to the next stage. So what is the next stage after taking all these values? PDMS then will check our given assembly option. Okay, PDMS will check our given assembly option. As you can see under this assembly tab, that our given assembly option in this case is suppose standard. Okay, in this case is suppose standard or in suppose curve. So PDMS has checked that our given assembly option is curve fit. So now PDMS will go to the assembly selection setting. Okay, this assembly setting. Currently we are using this test 2 setting. Okay. So under this test 2 settings, PDMS will check for this stair flight assembly, that is the curve fit. PDMS will get to here this curve fit, and as it is true, so you can see it here. If it is false, it will not be displayed here. So after that, PDMS will follow this curve fit, and following it, it will get the assembly item, that is this one. So PDMS then will follow this assembly item. Okay. So if you just click it here and if you just paste it here, like that, PDMS will follow it and PDMS will reach here. Okay, this is the stair flight. Now PDMS will use this RPath, this tree that is already been defined for using in the stair flight, and the stair structure, the stringer speaks information or like that. And PDMS will use this instance. As you can see, that there is no point SP. Okay, so you just have to define the general section and the spine. Okay, you just have to define the general section and the spine. All the point SPs will be calculated depending on the point arcs. Okay, depending on the point arcs of the R path. The R path will contain all the point arcs, so you don't need to define all these different point SPs. So you just have to define the gen6 and the spine, and the point SP will automatically be created by PDMS using this pointer reference. So PDMS will again follow this assembly item, will reach here, and after that it will take this R path, this street set and tree and this stair structure and the following gen6 for its template instances. Okay. So after following these template instances, in our case the handle is done. So again, if you click on update changes, you can see that PDMS has created this stair flight. So this is the total workflow of how a stair flight has been calculated and created in PDMS and the total administration part of it. So now what we will check how we can change all these things. Okay, how we can change or modify all these streams or something like that. So now just let me copy this. Okay, just let me copy this one, copy and paste it here. Okay. And just rename it as cell. Just rename it as cell. And now if I click on attribute, I will write here standard 2. It will be displayed here. So after that, we will just save it and we will just delete this template that I have previously created here. We will delete this template. This is our template one actually that I previously created. I will show you later how to create a template for a tree or something like that. Because first of all, just let us understand. So just delete this one from here. Okay. So now this field is empty. Okay. So now we have created a new stair flight assembly option. Okay. But now if you go here, as you can see in any of the settings, you cannot add a setting by clicking here. Okay. You cannot add a setting. For that, what you have to do, you have to create a new setting. Okay. So for that, you have to set the storage area. So again, what I have to do, I have to go here in settings. I have to create here a storage area, and then first of all, I have to choose the storage space for our standards, and then the storage space for our access setting. So all these things have been highlighted. So after that, I will click on apply. This means and save. Now again, I will click on create a setting, and now as you can see that the storage space has been displayed. It will create our required setting. Okay, I will rename it as SS1, and this will be a project setting type. So just apply. As you can see, this new application data file has been created. And now if you go here, as you can see that the numbers and assembly option named Shine Tree 2 has been included here. This is the latest created Stair Flight assembly option. So now if you go here, modify Stair Flight, this this ones and view color. So now as you can see, we have to change it. Just let me open and let me code it. We have to save this as our current setting. Now it has been saved as our current setting. Just save it. And again, we have to open it. Now, as you can see that under this assembly option, this last assembly option as shown here. Okay. So this is the newly created assembly option. Okay. But now, as you can see that under this treat set, okay, under this treat set, this is the treat. Nothing has been predefined. Okay, so if you just open a different treat set, you can see that a pane has been defined, or suppose you can define a template here or something like that. But in this case, nothing is defined. Even you can define a spec rate. Okay, you can define a spec rate here that I will show you just after this. So currently, nothing has been shown under this treat set. Okay. So if I just save it once, and if I just change it to standard to an evaluate Stair Flight, now if I update this. Now if I update this, as you can see that nothing has been created in place of these trees. So why nothing has been created? Because after calculating all these desired parameters, PDMS will look into this assembly for Stair Flight. PDMS is getting the scientific answer. PDMS will be following the scientific truth, and after that it will be checking this assembly item. So after this, PDMS will reach here, this category 7. And after that, PDMS will take this RPath instance, this stair structure instance, both PDMS are getting correct. But under this treat set and treat, PDMS is not getting any specification reference or assembly template reference or any specification or any pane under its hierarchy as well. So PDMS is unable to create this treat set following this assembly. Following this assembly. So for that, what you have to do, you can just create a pane under it. Okay? You can just create a pane under it. PDMS will create this one. So just for reference, just let me copy a page. Just for reference, just change it to evaluate and this one. And this is our newly created, newly modified Stair Flight. So we will just take the same references for our modification. So this will be 520, 530, 530, 520. So it will be easier creating this pane. So now what we have to do, we again go to here and we will click here as new pane. So we will be clicking here as new pane. So now if you go here and you just have to add the pane loop, the field, and again we have to add the pane vertices. 4 vertices will be required at least 5 you can give also, or to determine the center point, or if you want to give some curves or something like that. After that, what you have to do, you have to set this thing correct. So it will be 500 0, then it will be 500 300 like that, and again it will be minus 500 300, and the last one will be minus 500. So now, as you can see that I have defined this pane correctly. So now if I just save it once, and if I just take to the scientific tool and evaluate this here, right, and update changes, I think I have forgot to mention this thing. I forgot to mention this thing. So just let me mention. So I think the justification is correct. Just let me check the justification once. So what is the justification here? The justification is top left. Okay. I just forgot to give the thickness, so this year I will indicate it correctly. So again, we will just save it and we will go here and where this Stair Flight and update it. So now, as you can see, that this Stair Flight has been created. Okay, this is the pane that we have defined. So now PDMS is getting the assembly reference correctly. Previously, PDMS is not getting anything below this street. Okay. So previously PDMS is not getting anything below this street, but currently it is getting this pane. Okay. But the problem with this is the pane is having a fixed parameter. Okay. the plane is having a fixed parameter, that is a fixed piece for base value. Okay. So if you change this the width of this plane, okay. So if you just change this from 1000 to suppose say 1200 or something like that, if you back to and just when we leave it, okay, if you just update it, you can see that the all of the other parts have been moved, but there is a certain gap between the stair structure and this plane. Okay, there is a certain gap between the stair structure and this plane. So for that, you can do multiple things. So first of all, you can define a pane by rule. The second thing that is quite accessible, that is you can create a category in Paragon and you can refer it in the street, the statement. You first you have to create a specification. I will show you that later. The last one is you can just refer a template, okay, and you will just define all these template rules and everything. The template creation part I will cover in a later video. Okay. In the next episode, I will be creating a template specifically for this street, and I will be referring that template under this street, and I will tell how to modify all these things and ins and outs of template. In this episode, we will be creating or we will be referring the previously created treat specification. Okay. So we just change this to standard, complete and number changes. So just let me delete this page because it will be difficult to update this. So the most easiest thing to do is to refer spec. Okay. So if you go to Paragon, okay, if you go to Paragon, what you can do multiple things actually. But the easiest thing is to create a part one. Is to create a part one for our ASL parts. Okay, so this is the part one that I have created. You can just create it by command test new TRT, part electors or something like that. The purpose should be TREA because it will be used for trees. Okay, and after that the G part purpose is, should also be TREA. Okay. Now, under this G part, you have to refer the category. You can write or may not write this conversation, it is not important. But under this G part, you have to write this category. Okay. So, what is this category? This category is nothing but a structural category that I have previously created. This is a very simple category. You can just create it simply like you do create a category or something like that. Nothing fancy here. I have only mentioned this default width, default length, and field thickness. Okay. But the important part is the data set. So this is the important. And you can see that I have written here as expression. Okay, this expression is the treatment. So this GW and DTA, this is the attribute of the treat. Okay. In design, if you go here, if you go to here the Stair Flight, if you just write QEWIDTH, we get this width. Okay, this width is nothing but the width of the stair or the treat width that we have specified earlier. So this is the attribute. So in Paragon we have to refer this attribute. Okay. So only after referring this attribute, PDMS will understand how to change this width. Okay. Before that, PDMS will just put this 1000 width as a default width, and if you change the width of the stair, the width of the treat will not be changed. Okay, according to the width of the stair. So for that, what you have to do, you have to change this expression and you have to refer this attribute in the expression, and the default value can refer or may not. It will not be the thing because anyway it will be calculated. After that, you will be getting this treat depth. Okay. Again, this is the treat depth attribute. TREA double D. Okay. Again, in design, you just write it as TREA double D. You will get the treat depth that is 300 in our case. Okay. There is the 300 in our case. That is actually the going. Okay. That is actually the going. This going and treat depth. You can vary or may not vary it, but this is the treat depth attribute. TREA double D. Again, in Paragon, we have referred this as expression as TREA double D, the expression. Okay. And in treat thickness, I have referred it as a linear thickness. You can refer it by using the other thicknesses or something like that. But currently, I have referred the thickness as the default value, and it is the default that you just refer, may not refer it, it will not matter. Okay. So the three important data set values is treat width, treat depth, and treat thickness. You have to mention this as the expression and write it, the expression as the attribute of width, that is TB. In depth, you have to write it as TREA double D, that is the treat depth expression. Okay. And this is the thickness. Okay. So this is the complete category. This is nothing else. This is only for reference. So this is the category of a tree. Okay. After that, you have to refer this category name in this Gpart category. This is the category name, simple catalog field, and it is referred here in the Gpart category. So now, if I go here in that, first of all, just do a quick working paragraph and do a quick working design. Is something else you build or not, I do that. After that, what we will do, we will just open the attribute of this tree. Okay. After that, we have to refer this specification reference. So for that, we go to paragraph, and the specification reference will nothing but this name of the G part. Okay, this name of the G part will be the specification reference for the tree. So for that, you have to go to design, and you have to write here the name of the GPod. Okay, as you can see, the name of the GPod has been defined, and as you can see that our this is the assembly template, and it has been shown here. Okay, so now if you just save it once and just remove it because you know doing that. Again, now if you go here in the stair and back to modify flight and change this particular. So just pick our required assembly, that is the science sheet in our case, and evaluate this here and update this thing. Okay. So now as you can see that the width is changing around with the width of this here. Okay. So now if I change it to 2000, sorry, 200 is not acceptable, as you can see this. That the minimum value is 800. That minimum value is taken, the video is taken from the standard that I have already said. So if I put here 2000, if I put here 2000, then you can see that the 2000 has been completed. So again, we will click on the Stair Flight. We will update changes. Okay. So now as you can see that PDMS is taking this assembly item reference, and PDMS is taking this sheet as its instance. Okay, as its instance to create it. And now as we have referred this specification reference here, so the width or the date will be changing according to the stair line. So this is how you can create fancy reference or something like that, like in curves or something like that. Yeah. Okay. So this will be our final product. Okay. So in this episode, we have discussed all the workflow, starting from enabling the access to ladder module. Again, we have checked how to include the database under the master database that we are currently working on. And after that, we have checked how to create Stair Flight. After that, we have checked how PDMS is creating the Stair Flight for us, how PDMS is calculating all these values using which formula, how that formula has been defined. After that, we have discussed that how PDMS is using the min-max criteria. Okay, how PDMS is using the min-max criteria that is already provided under the ASL standards. And after that, PDMS is using the assembly stair flight thing that we have discussed here, that we have given here. And following this assembly thing, PDMS is using the assembly selection part. In assembly selection part, PDMS is using this standard tool thing to get to this assembly item. After that, PDMS is reaching this assembly item, and from there, PDMS is getting the instances of this R path, the street sets and trees, these stair structures like that. After that, we have learned that how we can create part called partimeters or GPart, the specification of a tree specification, and the data log structure section and structure category for our tree, how we can refer that in this GPart, how we can refer this GPart in our specification reference for this tree. In this section, we have discussed all these detailed work. We have discussed all these detailed work. In the next episode, what we will do, we will create a template containing a grading proper sheet. Okay, a template for containing a grading proper sheet, and we will create that template, and we will refer that template under this sheet category, and we will create a perfect stair like this. Okay, as you can see, that both this is not a hand created thing. This is all our category items. Okay, this is all our category items. If you go here and see, you can see that this is the template that I've been using for creating the street sale. And again, if you go to this, you can see that this is the fitting that I've been using. Again, with the template, so we will be discussing all these street details and the panel details in the next episode. Now, final product will look something like this. So, for this episode, it will end here, and in next episode, we will discuss all these things.